So, good morning. Today I'm going to talk about the pattern recognition project. And my project name is Handwritten Digit Recognition based on Deep Learning CNS method. And first, let's talk about the outline of my project. First, I will introduce the history of the deep learning, and then I will have an introduction to the deep learning algorithm. Then I will introduce the convolutional network. After that, I will show you guys the implementation of CNS mixed dataset. After that, I will show the experiment and the evaluation. At last, I will have a short demo about my program. First, let's talk about the history of the deep learning. I think it's a very useful topic for learning the machine learning. First, in the late 1980s, the invention of backpropagation algorithm artificial neural network has inspired the machine learning. It was found that the use of BP algorithm can make an artificial neural network model learning a large number of training samples from the statistic law. At that time, the artificial neural network, which is called multi-layer perception, is only a kind of shadow model, contains only one hidden layer. And then in the 1990s, many kinds of shadow machine learning shadow model are proposed, such as the spot vector machine, the other boost, and the logistic regression, and so on. This model can be regarded as containing a hidden layer, such as the SVM and boosting, or no hidden layer, like LR. And compared with this kind of statistic-based model, neural network can be very complicated, which needs much training experience and techniques. So the development of neural network can be very slow. In the 2008, the Dr. Hilton in Toronto published a new neural network algorithm. He shows that artificial neural network hidden layer has excellent characteristic learning ability, which is able to gain more fundamental characteristic of the data. And the main drawback of the classical neural network is that the computation time is very, very slow. And he treats these problems by the layer-wise pre-training. Let's see this example. This is a very complicated function, but it can divide it into 4 steps, 5 steps, and in each step, there are only one function, and the combination of 5 steps can be very flexible and complicated. The main algorithm of the machine learning, Dr. His idea is that first it builds a single layer neuron layer by layer, so that every time it just training a single network. After training all layers, Dr. Hilton uses the wake-sleep algorithm turning. And see this example, there is many connections between layers, and each time we just train one layer, so we reduce the complexity of the neural network. So in this project, I just focus on the convolutional neural network, and there are some other neural networks, but at this time, I just implement this. Since is the first truly successful training multi-layer network structure learning algorithm. It uses the spatial relationships to reduce the number of the parameters needed learning in order to improve the performance, and since as a deep learning framework proposed in order to minimize the data processing requirements. The image at the lowest level of hierarchy inputs information and then transmits sequentially to different layers in each layer to obtain the most significant feature of the observed data through a digital filter. This method can be accessed to translation, scaling, and rotation of the silence feature. and show as this figure in below. And please see this example shows the structure of the convolutional neural network. Input image can be trained through and three filters and can bias convolution. After convolution, produce three feature map in layer C1, then characterize in the map for each group of 4 pixels and then summing the weighted value. S2 obtained, then S2 obtains the characteristic map of 3 layers by a function. This map and then can get into the filter with C3 layers. The same hierarchy again. And S2 produce S4. Generally, the C1 is a feature extraction layer. Each neural of the input and the local respective field and previous layer is connected, and layer S is a characteristic mapping layer. Each feature is mapped to a plane. The weights of all neurons in the plane are all equal. And let's talk about some mathematical background of the neural network. This is the backpropagation of the CNN. Let's see the first function. Let delta to power L plus 1 be the error term for the L plus 1 layer in the function of G, where W and B are the functions or parameters, and XY is the data of the training. If we consider a connection between L and L plus 1, the equation is shown as the first function, and the gradients of J is shown as the second and third function, and the error propagation is shown as a fourth function, where the filter number is k, and zk is the activation function derivative. For instance, if we have a mean pooling and then sampling sample uniformly distributes the error for a single pooling unit among the units which fit into it. Finally, to calculate the gradients, WRT to the filter map, we rely on the burden-handling convolutional operation again, and the error matrix then the same way of the convolution layer. The calculates the gradients of the filter map shown as the last function, where Bi is the input to the else layer, and Bi1 is the image of the input. Let's talk about the implementation of the CNN in the mist. It is proposed by the Microsoft, a very simple CNN implementation, and the general strategy of the convolutional network is to extract the simple feature at the higher resolution and then convert them into a more complex feature. A convolution kernel, say as this figure, is size 5 is shown in the figure, with the no padding, the subsampling of 2, and the kernel size is 5. Each convolutional layer reduces the feature size from n to n minus 3, divided by 2. Since the missed input size is 28 to multiply 28, the nearest value which generates the integer size after 2 layers is 29 multiply 29. The first feature layer extracts very simple features. The first 2 layers of the neural network can be reviewed as a trainable feature extraction. For the mist, it is enough to use 100 hidden units, and this is shown to be very efficient. And this is some implementation of the CNN in the midst. Uh, this is the backward and forward propagation of the neural network. And yi and hi are the gradient and the activation of component J according to the layer L. And wi is responsible for the make connection with two layers as the weight. Uh, the implementation can be very time consuming. In order to simplify the computation, it provides another solution called push. Say the second function, the main idea is to push the gradient to the lower layer. The equation is shown below. And this is the main implementation of the CNN. And then I will show the experiments and the evaluation. The environment of the program is that I use the Mac iOS X as the operation system and the MATLAB 2014B as a software and use the means the data set as shown before. The because my laptop do not contain the did not contain the discrete GPU, so I cannot implement the CUDA, which can improve the performance of the consuming time. So I just run it on the CPU. The training set is 50,000 patterns, and the validation set is 10,000 patterns. And this is the sample of mist which is generated from my program. Uh, this is the experiment's result. We can see from the top of the table is the implementation of some state-of-art algorithm, including the unsupervised learning model such as the SVM, BOAST, and the MLP, and some very advanced deep learning method uh, such as the committee CNNs and simple CNNs, which can achieve a very good performance. My implementation's error rate is 1.8, which is reasonable and has improved the efficiency of the CNN's implementation. And the test sample is 10,000 as shown before. Uh, this is the error rate of each epoch. Each epoch will be used as a training sample to test the data set and give an average error related based on the 10 digits. At the beginning, the epoch can show a very low error, a high error rate, and as the iteration of the epoch, the the rate of error reduced significantly, and after the 30 iteration, it can achieve a very good performance. And this is a figure of showing the error rate of each digits. The 1 and the 0's error rate is the lowest, nearly 0, and the 8 gets the highest error rate, which is about 2 to 4%. What is more interesting is that the epoch 10, 1, 10, 20, 30 shows the simple curve of the error rate, but it's apparently that the epoch 30 shows a lower error rate. It proves that the success of the implementation. And I think there is something to be done to optimize my program, but this is all has been done by in the project. So let's show the demo of my project. This is the this is a program of my project. We can see that this is a data set of the means. There are one training sample and one test sample. In the training sample, it contains 50,000 data, and in the test sample, it contains the 10,000 sample. And this is some implementation of CNN CNN algorithm, and it contains the layer, the adapters, uh, such as the pull and the convolution function, and the some other parameters. Uh, this is some shared data, and let's show the demo of the test sample. Because the training process can be very time consuming, and it may take more than 1 hour to finish it. So I just use the pre-trained training sample to test the data. Uh, let's show from this sample. Before we talk about the test demo, first we can show the configuration of my demo. It contains the input size, the forward path scheme, and the non-linearity, and output activation, and kernel size, and some other parameters. Uh, this is the test demo of my project, and let's just run it. First add it into the path, and then run it. This is a figure generated from my project, shows the sum of random test sample, and it is testing. Now it has finished. It shows that it achieved 98.2 accuracy of the test sample, which is shown in my presentation before. And let's show the demonstration of the training sample. The demonstration of the training sample can be shown like this. First, add them into the data, data set, and then we open the demo. This is the main program of my demo. First, we run it. And in this demo, I will print the error rate of each output. Each digit shows 1,000 training sample has been trained, and after the 2 shows that 2,000 training sample has been trained, and after 10,000 training sample has been trained, it can be regarded as a epoch, and the epoch then use the training sample to test the random test sample. Let's show it. This is the train test sample, and this is it is running again. This is for the 11,000 and 12,000, and the test error rate we can see is very high because it is the first epoch, and the average of the test error rate is about 92%. And after the second epoch, we can see that the average of the error rate is dropped to the 95. uh, it can achieve a better epoch if after several iterations. So there is no time to talk more about the training demo. So we just quit it. So this is all about my presentation. And apart from learn implementation the CNN network, I also learned something about the deep brief network, the restricted Boltzmann machine, and the sparse coding and the auto encoder. Uh, I think I have a long way to go in the pattern recognition field, and I'm very lucky to take this course. And the main effort of my uh, of this course is to implement the things on the mixed dataset, which is a very classical problems in the machine learning. So thank you.